For this scenario, if neutral is grounded, when a single line to ground fault has occurred in line R, the fault current having a path flowing to the ground to neutral point. Whatever the current flow in R phase is measured as fault current. What is voltage VR across this line R? Between these two terminals, there is no voltage present. It means the voltage is zero at this point of time. When fault is occurred from this line R, which is shorter to ground, so right here VR equals 0. What will be the value of IF? The value of fault current IF is equal to IR. So right here, the line current IY and IB is still remain 0. We will evaluate how to find the sequence components by using transformation matrix. Next, we need to find out the sequence current and the sequence voltage. From that value, we can understand the interconnection of the three networks: positive sequence, negative sequence, and zero sequence. The following method is the sequence current using transformation matrices. IR0, IR1, IR2 equal 1 by 3. The magnitude of zero sequence 1, 1, 1. Magnitude of positive sequence for IR1 is 1 alpha alpha square. The magnitude of negative sequence for IR2 1 alpha square alpha. The line current IR equal to the fault current IF. The line IY is equal to 0. The line IB is equal to 0. IR0 equals 1 by 3 times 1 times IR plus 1 times IY plus 1 times IB. IR0 equals 1 by 3 times IR plus 0 plus 0. Since IY equals 0 and IB equals 0, let us simplify. IR equals 3 times IR0. Since IR equals IF equals 3 times IR0. IR1 equals 1 by 3 times 1 times IR plus alpha times IY plus alpha square times IB. IR1 equals 1 by 3. Just put IR plus 0 because alpha times IY equals 0 plus 0. Alpha square times IB equals 0 equals 1 by 3 1 times IR plus alpha square times IY plus alpha times IB. IR2 equals 1 by 3. Just put IR plus 0. IY equals 0. Alpha square times IY equals 0 plus alpha times 0 plus 0. Let us simplify. IR equals 3 times IR2. IR equals IF. IF equals 3 times IR2. So we already identified the sequence current. Let me write the sequence current here. IR0 equals IR1 equals IR2 equals 1 by 3 IR equals 1 by 3 IF. Three sequence current are equal, so the three sequence network connected in series. Positive sequence, negative sequence, and zero sequence. Let us draw the positive sequence network. IR1 is composed of an EMF voltage source in series with the positive sequence impedance Z1. BR1 equals ER minus IR1 times Z1. Let us draw the negative sequence network. IR2 is negative sequence network. Similar to positive sequence network, may have different sequence impedances, and the negative sequence network does not contain any voltage source. BR2 equals negative IR2 times Z2. Let us draw the zero sequence network. IR0 does not contain any voltage source. The impedance included, the neutral is 3 times its value. BR0 equals negative IR0 times Z0 plus 3 times Zn. The three sequence current are equal, so the three sequence network connected in series. Positive sequence, negative sequence, and zero sequence currents are equal. They are interconnected in series. The sum of three phase voltages is equal to 0, so there is short circuit in series combination of the three networks. BR equals BR1 plus BR2 plus BR0 is equal to 0. BR0 equals minus IR0 times 0 impedance Z0 plus 3Zn. BR1 is equivalent to ER minus IR1 times Z1. BR2 equals negative IR2 times Z2. Let us transform and simplify the equation. The value of IR0 equals ER divided by Z1 plus Z2 plus Z0 plus 3 times Zn. Since fault current IF is equal to 3 times IR0, so IF divided by 3 equals ER divided by Z1 plus Z2 plus Z0 plus 3Zn. Then simplify, transpose. IF fault current equals 3 times the ER divided by Z1 plus Z2 plus Z0 plus 3 times Zn. So this is the final equation for the fault current when the system is unloaded. If the system is loaded, just add 3 times ZF, impedance of the load.